With the example, we want to write only yp, not the general solution. We want to only yp for the differential equation. But we know it that before writing yp, we need the yc. So we can see if the roots are repeated, we can modify our yp. So we take first the homogeneous part of the solution. Then this here part 1 is, we take the differential equation y triple dash minus 2y double dash is equal to 0 to find yc, the homogeneous part of the solution. So we put here y is equal to e to power mx, and we get here characteristic equation is m cube minus 2m square equal to 0. We take m square common, we get here m minus 2 equal to 0. Our roots are m equal to 0, m equal to 0, and m equal to 2. So we can write my y c is equal to c1, e to power 0 is 1, c2x plus c3 e to power 2x. This is my yc. Now I have yc, I have f of x. I can decide about my yp. So here is my f of x. My f of x is equal to 5 plus e to power 2x plus x cosine x. And my yp is equal to c1 plus c2x plus c3 e to power 2x. Am I right? My yp will be equal to, here we get here a plus b e to power 2x plus c x plus d, we're having cosine x, and then we're having here e x plus f sine x. So this is my yp. Now I want to see, do I need to modify this one? I can see here, this is my x is repeating here, I multiply by x. So no, it's not repeating. But here we get here c2x, it's repeating with this one. So we multiply again by x, we get here x square. No, this is not repeating. So because of these two terms, we need to multiply here by x square. When we write a is repeating with c, and then we write ax repeating with c2x. Again, no, it's not repeating. No, linearly independent, we can write the linear combination. We come to the next term. Here is c3 e to power 3x, this is b, they are repeating. So they are repeating again, we multiply by x, and then they are not repeating, there is no sine cosine here. So we have the modification in our a and b in our b. So we can solve this one, finding the value of a and b, c. And this is our solution. We need only our yp. Again, there are two parts. First we find yc, because we need here to check that here the no roots are repeating, and this was our yc, not yp, and this is our yp. And then we check here, because the roots are repeating here, so we multiply by x square. This is also repeating here, we multiply by x, and rest is okay. So this is my yc. I find here a, b, c, d, and ef, substituting in my differential equation, and finding the value of a, b, c, and d, substituting there, get yp, and I can write my general solution. I have the example, we want to solve this non-homogeneous differential equation second order by method of undetermined coefficient. Again, we'll find here, we need to find the homogeneous part yc. We find here yc and yp. To find yc, we take homogeneous part d2y by dx square minus dy by dx minus 2y equal to 0. Now our substitution as before, to find the characteristic equation e to power mx. We put here this one, we get here m square minus m minus 2 equal to 0. We write the factors. That there we get multiply, get minus 2, add, we get here minus 1, is m minus 1, m minus 2, m plus 1 equal to 0. We get the roots, m equal to 2, m equal to minus 1. I get here my yc is equal to c1 e to power minus x plus c2 e to power 2x. This is my yc. Now I want to find my yp. I have yc, I can check here, what's my yp? I have my f of x. My f of x to find the part 2 is to find the particular solution yp, and I'm having here my f of x is equal to 2x square. So my yp in general is polynomial function of degree 2 ax square plus bx plus c. We check with the yc. We find here c1 e to power minus x, no minus x there. c2 e to power 2x, there is no value which is repeating. So we don't need any modification. Now we substitute this in our differential equation. To substitute it, I need y dash and y double dash. So what's my y dash? My y dash is equal to 2ax plus b. What's my y double dash? My y double dash is 2a. I substitute this one in my differential equation. What I'll get, y double dash is 2a. Then we having here minus y dash multiplied minus y. We get minus 2ax minus b multiplied minus 1. Then here is minus 2y multiplied minus 2 is minus 2ax square minus 2bx minus 2c, and this is equal to what? This is equal to right hand side. Right hand is 2x square. Here is 2x square. Now to find the coefficients a, b, and c, we compare the coefficient of x square, then the coefficient of x is 0 here, and coefficient constant is 0. We compare the coefficient of x square, comparing the coefficient both the side, we get here minus 2a on the left hand side and 2 on the right hand side. Then I compare the coefficient of x I get here minus 2a, then I get here minus 2b, and that's equal to 0. Then I compare the coefficient of the constant x to the power 0, I get here 2a, then this minus b, then going there we minus 2c is equal to 0. From the first equation I can find the value of a, which implies a is equal to minus 1. Then here the value of b, we can see it here, minus 2b, minus 2a, 2b. We put the value of a become minus 1, this become 2. So mine is equal to 2 minus 2b is equal to 2a, and we get minus 2b is equal to minus 2, and that give me b is equal to 1. Again, look here. I take 2a to the other side, we get minus 2b, this become positive. And now we're having the value of a is minus 1, put minus 1, we get here minus 2. Divide by minus 2, we get value of b equal to 1. Now put the value of a and b here, minus 2c, we take a and b on the other side, we get here minus 2c is equal to, which is minus 2a, and then we haven't taken this one, this is plus b. So put the value here, I get here minus 2c, is minus a, minus plus become 2, and b is 1, so get here 3. My c is equal to minus 3 by 2. So I can write here my a, value of a is equal to minus 1, value of b is equal to 1, value of c is equal to minus 3 by 2. I put the value of a, b, and c in yp. So my yp comes to be equal to a is minus 1, we get minus x square, b is 1, plus x, c is minus 3 by 2. I want to write my general solution. So my general solution, as I described before, that is the combination superposition of yc and yp. What's my yc? Yc is c1 e to the power x, e to the power minus x, plus c2 e to the power 2x, plus yp is minus x square plus x minus 3 by 2. So again we check it, that we don't have any repetition, there must be a linear combination, e to the power x not repeating, e to the power 2x not repeating, and the values are not repeating. So this is our solution of the differential equation here that we have done, that we are having here the values. We are having here this our differential equation is a non-homogeneous form, and we use this differential equation to write the solution of this one. So we are having here the part 1, we find yc, this is our part 1, and then we are having here part 2, we find here yc by usual method, this is our yc, we find the characteristic equation, then factorization, and write. Then second part is to find yp, we're having the function f of x, we write our yp. Then there is no modification yp because we compare this yc and yp. This is my yp, this is my yc. We compare them. No root is repeating. If root is repeating, we modify our yp, multiply by x. Then we substitute, find here the value of coefficient, undetermined coefficient a, b, and c. Substitute in the differential equation. Finding y dash, y double dash, substitute it in the differential equation. is equal to 2x squared. This means we can write here 0x and 0. Now we compare the coefficient of x squared. This here is coefficient is minus 2a, and here coefficient is x squared. So get minus 2a is equal to 2. And then for x, this is contain x, this contains x, and there is x here. So we get to minus 2a minus 2b equal to 0. Then with the constant, we're having here a constant, we're having here a constant, and we're having here a constant, and is equal to 0. We solve this, these equations, and we get the value of a is equal to minus 1. We get the value of b is equal to 1, and value of c is equal to 3 by 2. We put the values in our this equation, yp. So get here a, b, c, put in yp, a equal to minus 1, b is equal to 1, c is equal to minus 3 by 2. Then we write our general solution. Our general solution is combination of yc and yp, and this is my y, the general solution.